This section gives a brief introduction to scene properties. Sometimes when designing your logic, you may want to rely on values that come from a view, like position, rotation, or distance to something. In this case, scene properties will come in handy. Scene property acts almost like a regular property. The only difference is that its value is set in the view. Let's take a look at a simple example. I have already got my diagram set up. I have a triangle element, which has a property of type square called target. Both square and triangle elements have their views defined. Additionally, my triangle view has a target changed binding. In my scene, I've already got a few triangles prepared. Each of those has a link to the square, which is the only one in the scene. So I want those triangles to always face my target, and somehow I need to transfer the position of my target to the triangles. And this is certainly a property that belongs to a view. That is why I'm first going to define a scene property on my square. To do this, I create a regular property on my square called avatar position. This is going to have a type vector 3, and I link this property to the view. Now I save and compile. If I control-click on my square, the controller will be opened for me. If I refer to my square.avatar position, you can see that I have this property available. Also, I can go back to my editor and control-click on my square view. As you can see, I've already got my transform cached. Also, I got a very special method generated for me called calculate avatar position. And notice the naming convention, calculate scene property name. If I override this, I can explicitly tell the uFrame how to get the value for this property. In my case, it's going to be transform.position. Under the hood, this one will be invoked every update method, so the uFrame can keep track of this and update the property on the view model accordingly. Now back to the editor and control-click the triangle view. As you can see, uFrame has already generated target change handler for me. Inside of this, I want to bind to property. This is going to be triangle.target.avatar position property. And I also want to specify a handler. This p is going to be of type vector 3, and this will be equal to my avatar position value at the time of binding invocation. And the last thing here, I want this binding to be disposed once my triangle.target property is changed. Because whenever I change the target, I want to unbind this. Finally, I will drop in some code which does nothing more than facing my triangle sprite to the specified P point. Now if I hit play and move my square around, you can see that all the triangles follow him. Perfect. So far, we have used the scene property of one element inside the view of another element. And this is a good example of how easily you can kinda access the view properties without actually getting a reference to the view. Indeed, in our triangle view, we did not have to explicitly find the target view. Instead, we can just have a reference to the target view model, and this way we can retrieve the avatar position value. But this is not the only use case. You can use scene properties to describe some logic in the controller, or you can create computed properties based on your scene properties. As I have already mentioned, calculate avatar position method is going to be invoked every update cycle to keep avatar position variable up to date. That's why the question of performance arises. So let's see how we can tweak the things to be as efficient and flexible as you want. On my square view, I got another method available called getAvatarPositionObservable. And notice the naming convention again. Get scene property name observable. If I override this, I can explicitly specify what kind of observable I want to be used in order to update my avatar position. Whatever you return here is not necessarily going to use calculateAvatarPosition method. In fact, if you're familiar with reactive extensions and observables, you can be as creative as you want here and create your own observables. If you are not familiar with the Rx, then uFrame provides you with some helper properties which are in fact observables. One of those is position as observable. It's an observable object which belongs to this particular view, and you can subscribe to this using some handler with vector3 argument. If you return this, uFrame is going to automatically subscribe to this, and instead of using this guy every frame, it's going to use this observable to update your avatar position. The good thing about this property, or about this observable, is that it only invokes its handlers when the position of their view has actually changed. So this allows you to achieve bleeding edge efficiency when it comes to updating your scene properties. If we go back to the editor and hit play, we can see that indeed it works. But now it's much more efficient. So far, I've been talking about the performance, but what about the flexibility? Again, when you have an observable, you can create other observables using some handy chaining methods. Let's say I want my position to be updated every time it's changing, but only once per second. I can easily do this by using the sample extension method with time span interval taken from seconds. Now my property is only updated once per second, and only when it actually changed. As I have already mentioned, this new observable is not going to use your calculate avatar position. To force it to do so, you can just select whatever comes in and return calculate avatar position. In this case, you are not going to use whatever comes from this position observable. Instead, you want to return your calculate avatar position, but this will only be invoked once the actual position is changed. So basically, you can divide it into when to do it and actually what to do. So here you can provide any kinds of calculations, given that you actually use this method.